This information is going to be very relevant to what you're going to be seeing on the Chapter 4 exam. So I want to go over it very carefully and clearly. This is bond identification. As indicated with the last lab, you'll not be responsible for drawing what are called these electron dot structures. That was to show the 2 and the 8 rule. This is to show how do you know if you have a covalent bond or an ionic bond. So let's go ahead and distinguish the two types of bonds first of all, and we're going to review this from lecture. So we have a covalent bond and we have an ionic bond. If you can write that down on the bottom. So I want to tell you how to always precisely define if you have a covalent and an ionic bond. With a covalent bond, you're always going to have 2 nonmetals. We'll take a look at that on the periodic table in just a minute. With an ionic bond, you will always have a metal and a nonmetal. If you remember ionic bonds, ionic bond is when you have a charge, is when you have a difference in electrons. It's when you've had something gain and lose an electron. It's when you have this positive ion, such as sodium, and you have a negative ion, such as chlorine, which is a nonmetal. And if you notice, you have these opposite charges, and those are going to attract towards each other. That's what an ionic bond is. So going up to problems numbers 1 and 2, when atoms share electrons to fill their outermost energy levels, so that right here we're looking at this word share. What type of bond do you have when you're sharing electrons? Well, the last lab that we did, we were looking at sharing electrons, and those were all covalent bonds. Again, covalent bonds is taking place with 2 nonmetals. Atoms that transfer electrons, this is when they lose or gain electrons. That's when they're forming the ions. So when they transfer their electrons, they're either giving them or they're receiving them. So here, the positive ion, this is going to be losing an electron, and the negative ion is going to be gaining the electron. So when we have that transfer, we are having an ionic bond. So let's take a look at the periodic table. You'll need your periodic table for this. And let's do a quick review. Okay, I'm going to put this in view for you guys. Group 1, these are called your alkali metals. Group 2, these are called your alkaline earth metals. This giant block in the middle is called your transition metals. In chemistry, we'll take a look at a couple of these that sort of zigzag down. They're called metalloids, but for now we're just not going to worry about them. So we have these metals that are over here, and these are all on the left-hand side, and we have these over here, which are your nonmetals. These are on the right-hand side. So if it is within group 1, group 2, or these right here, these are going to be metals. If you remember from one of the videos that we saw during one of our digital days, before we had the quarantine, it was chasing or hunting the elements, and it talked about how about 80% of the elements on the periodic table are metals. We have this little section over here that's going to be our nonmetals. Okay, so you have to remember your nonmetals are over here because these are your alkali metals, your alkaline earth metals, and your transition metals. All your metals are on the left-hand side. Your nonmetals, think of these are called your noble whats? Your noble gases. Okay, so these are your nonmetals because the gas is not a metal. Now, the exception to this is also the hydrogen over here. Okay, hydrogen is not a metal, but these, again, all these here are your metals. All these guys on the other side, like your noble gases, nonmetals, and all these over here are nonmetals as well. So with that in mind, we have 2 oxygens that are combining together. Is this going to form a covalent bond or an ionic bond? Well, you have to ask yourself, is this a metal and a nonmetal, or is it 2 nonmetals? Well, oxygen is, what is it? Is it a metal, or is it a nonmetal? And they're both nonmetals. So we have two nonmetals, therefore it's going to be a covalent bond. Take a look at the next one. The next one, we have potassium and we have chlorine. Potassium is over here on the periodic table. Chlorine is over here on the periodic table. What type of element is potassium, K? Is it a metal or a nonmetal? What type of element is chlorine? Is it a metal or a nonmetal? Potassium is a metal because it's an alkali metal, and this is a nonmetal. Therefore, I have a metal and a nonmetal. Therefore, I have an ionic bond. Can you guys figure out what this one's going to be? I'd actually like you to pause and fill out the rest of these to see if you could do them, and then we're going to come back. Hopefully you paused and finished this. Now you're going to be able to fill this in. We have iodine and iodine. Well, here's a key concept. If you have two of the same and only of the same, you're always going to have two nonmetals. You can't have two metals because can you imagine if you have a potassium and a potassium? You have two positively charged things. Those things are going to repel away from each other. That's not going to work. Or a potassium and a sodium. Those are positively charged. They're going to repel away from each other. You can only have two of the nonmetals, actually, that are going to be grouping together. So two nonmetals, this is going to be covalent. Now we have sodium and sulfur. Sodium is Na. There's my sodium. It's a metal. Sulfur is a nonmetal. I have a metal and a nonmetal, therefore this is going to be ionic. Lithium and chlorine. Lithium is a group 1 metal. Chlorine is a nonmetal. So I have a metal and a nonmetal. This is going to be ionic. Now guess nitrogen and nitrogen. It's two of the same thing. It's therefore going to be covalent. And if you indeed look at it on the periodic table, it's over on the right-hand side, and this is where your nonmetals are.